Hello students, myself Varekar A. We already started a topic, vectors. This is our fifth lecture. In last lecture, we studied distances of a point from the plane, from the point and from the origin and its examples and theorem. Now start with this lecture. First point is section formula. There is two theorems based on section formula. Theorem first, the statement of this theorem is section formula for internal division. Let A of A bar and B of B bar be any 2 points in the space and R of R bar be a point on the line segment AB, dividing it internally in the ratio ms to n, then R bar is equal to mb bar plus na bar upon m plus n. This is the section formula for internal division. If there are 2 points A and B and position vector of a point A bar and position vector of a point B is B bar, if we join this line and R point whose position vector is R bar, divide this line internally in the ratio ms to n, then position vector of R bar is equal to mb bar plus na bar upon m plus n. So start with the proof. Consider a line segment AB. Consider a line segment AB. Look at in this diagram. R be the point on the line. This point R divide the line segment internally. So here it is in the form of ARB. That is AR and RB bar. AR bar and RB bar are in the same direction. Now, this R point divide this AB in the ratio ms to n. So, by ratio AR upon RB is equal to m by n. If we cross multiple here, so n into AR is equal to m into RB. Now, as MRB bar and NAR bar have same directions and magnitude. These two have a same directions and magnitude. So we write NAR bar, NRB bar is equal to NAR bar. So these two values are also equal. So what is RB bar? RB bar is OB bar minus OR bar. And what is AR bar? AR bar is OR bar minus OA bar. So, M into OB bar is B bar, OR bar is R bar, OR bar is R bar, OA bar is A bar. If we multiply by M, multiply by N, what we will get? MB bar minus MR bar is equal to NR bar minus NA bar. Similar terms which contains R bar get on one side. So MR bar plus NR bar here. And here MB bar plus NA bar. We take R bar common from these two terms. Then M plus N R bar. So R bar is equal to, this bracket is multiplied to R bar. So divide here. So MB bar plus NB A bar divided by M plus N. This is very simple theorem. Then note. First note. If A is equal to A1, A2, A3. A has a coordinates A1, A2, A3. B has a coordinates B1, B2, B3. And R has a coordinates R1, R2, R3. Divides line segment AB. This R divides line segment AB in the ratio ms to n. Then Ri bar is equal to mbi bar plus nai bar upon m plus n, where I is equal to 1, 2, 3. This depends on the coordinates. Then next, midpoint formula. If R of R bar is a midpoint of the line segment AB, R is a midpoint of line segment AB, then M is equal to N. Obviously, R divides AB in an equal length. So M is equal to N. So M has to N. Then its ratio is 1:1. If its ratio 1:1, so M is equal to 1, N is equal to 1. Then by section formula, R bar is equal to 1 B bar plus 1 A bar upon 1 plus 1. That is, R bar is equal to A bar plus B bar divided by 2. So here we studied two formulas, section formula, that is R bar is equal to section formula for internal division, that is R bar is equal to MB bar plus NA bar upon M plus N, and midpoint formula, which is R bar is equal to A bar plus B bar divided by 2. These two formulas are very important for the examples. Then next theorem, section formula for external division. There is only change by a minus sign. In internal division, here is plus sign, and in external division, here is minus sign. So what is the difference? Let A of A bar and B of B bar be any two points in the space, and R of R bar be the third point on the line AB. This is a third point on the line AB, dividing the segment AB externally. In section formula internal division, there is division is internally division, and here division is externally division. So externally in the ratio M:N, so R bar is equal to MB bar minus NA bar upon M minus N. Now R divide externally in the ratio externally to AB. So here either ABR or RAB. This is in the form ABR or RAB because R divide externally to the AB. So we consider ABR. We assume that it is ABR. So ABR, this R divides AB in the M:N. So AR is M and BR is N. So this AR is M and BR is N. So AR upon BR, here AR upon BR, which is equal to M by N. AR upon BR, which is equal to M by N, and this AR bar and this BR bar has same magnitude and same direction. Therefore N of AR bar is equal to M of BR bar. So what is AR bar? AR bar, it is R bar minus A bar, or it is OR bar minus OA bar, which is R bar minus A bar, and M into bracket. What is this? This is R bar minus B bar. So we multiply N to the bracket, M to the bracket. So N R bar minus N A bar, which is equal to M R bar minus M B bar. So we take R bar terms on one side, that is M R bar minus N R bar here, and this minus MB bar is on here. So MB bar minus NA bar is equal to M R bar minus N R bar. We take R bar from this term. So R bar into bracket M minus N. So R bar is equal to MB bar minus NA bar upon M minus N. So this is the section formula for external division. Now first note, whenever the ratio in which point R divides the join of two points A and B is required, it is convenient to take the ratio as K:1. Then for division internal, R bar is equal to K B bar plus A bar upon K plus 1. Here M is K and N is 1. And for external division, R bar is equal to K B bar minus A bar upon K minus 1. That means, suppose there is a line segment AB and R divides in some ratio, and we have to find that ratio. In example, we have the position vectors of the point, but we have to find the ratio in which that point divide this segment. For that, we conveniently take the ratio k as to 1. And after that, finding the value of k, we substitute here value of k and we will get the ratio. The next note is, in triangle ABC, centroid G divides the median. This is the triangle ABC. If A bar, B bar, C bar are the position vectors of the vertices of the triangle, and G bar is the position vector of the centroid of the triangle, we know that this centroid divides the median into 2:1 ratio. So the G bar is equal to, formula for G bar, centroid G bar is equal to, position vectors of G bar is equal to A bar plus B bar plus C bar divided by 3. The next, in tetrahedron, here is the tetrahedron A, B, C and D. This is a three-dimensional figure, A, B, C and D. G is the centroid. G is the centroid of the tetrahedron. So this centroid divides this line into 3:1, AE into 3:1 ratio. So G bar, the position vectors of G, which is equal to G bar, is equal to A bar plus B bar plus C bar plus D bar, where A bar, B bar, C bar and D bar are the position vectors of the vertices of the tetrahedron, and divided by 4. This is the formula for centroid of the tetrahedron. The next example, first example, find the position vector of a point R which divides the line joining the points P and Q, whose position vectors are 2i cap minus j cap plus 3k cap and minus 5i cap plus 2j cap minus 5k cap in the ratio 3:2 internally and externally. We have to find the position vector of R, and we have given position vectors of P and Q, and we have the ratio 3:2. So we have to find internally and externally in both ways. So first, position vector of P is given, position vector of Q is given, and R point, position vector of R is suppose R bar. Then it divides the segment PQ in the ratio 3:1, 3:2. Then by section formula for internal division, firstly we have to find by internally. So section formula for internal division, here R bar is equal to 3Q bar M A bar plus NB bar. That is 3Q bar plus 2P bar divided by 3+2. Q bar is here, P bar is here. So multiply by 3, multiply by 2 and make an addition and subtraction. We will get minus 11i cap plus 4j cap minus 9k cap divided by 5. So coordinates of R is equal to minus 11 by 5, 4 by 5 and minus 9 by 5. This is the internally. Now second, externally, if R of R bar divides the line segment PQ externally in the ratio 3:2, what is the difference? Just change the middle sign, plus 2 minus, that is R bar is equal to 3Q bar minus 2P bar divided by 3 minus 2. So 3 into Q bar as it is minus 2 into P bar as it is divided by 3 minus 2, which is equal to minus 19i cap plus 8j cap minus 21k cap. So coordinates of R is equal to minus 19, 8 and minus 21. Then next example, Find the position vector of the midpoint M joining the points L 7, minus 6, 12 and N 5, 4, minus 2. This is the line segment LN and M is the midpoint of this line. We have to find the position vector of this midpoint. We know the formula of a midpoint, A bar plus B bar divided by 2. We change here formula by these letters. So here L bar is equal to 7i cap minus 6j cap and plus 12k cap. This is the position vector of L. Position vector of N, it is N bar is equal to 5i cap plus 4j cap minus 2k cap. Then by midpoint formula, M bar is equal to, we have to find the midpoint, M bar position vector. So M bar is equal to L bar plus N bar divided by 2. L bar is here, N bar is here, divided by 2, which is equal to, we add these two vectors, we will get 6i cap minus 1j cap plus 5k cap. We cannot write 1. So position vector of M is equal to 6i cap minus j cap plus 5k cap. This is our second example. Then next example, if the points A into bracket 3, 0, P and B into bracket minus 1, Q, 3 and C into bracket minus 3, 3, 0 are collinear, these 3 points are collinear, then find the ratio in which the point C divides the line segment AB and the values of P and Q. So solution is here. This question is most of the times asked for the board examination. Let A bar is equal to 3i cap plus p k cap. Here j cap term is 0. So p k cap. B bar is equal to what? Minus I cap q j cap plus 3k cap. And C bar is equal to what? Minus 3i cap plus 3j cap. K cap term is 0. Now firstly, the ratio, we have to find the ratio C divides in the line segment AB. Now we have to find the ratio. For that purpose, we studied in a note in last slide, that is, for the convenience, we take it as a k as to 1. Here, we take it as a lambda as to 1. This ratio, that is lambda as to 1. So C bar divides AB. Then by section formula, C bar is equal to lambda B bar plus 1a bar divided by lambda plus 1. Now there is a two sections formula, section formula for internal division and section formula for external division. To find the ratio, we always use the section formula for internal division. We always use this formula, not external division formula. Okay. Then here what is C bar? C bar is minus 3i cap plus 3j cap, which is equal to lambda into bracket B bar, we write here B bar plus 1 into bracket, we write here A bar upon lambda plus 1. We multiply this lambda plus 1 to this side, lambda plus 1 into this vector, multiply lambda to this, multiply 1 to this. We will get, after solving, we will get minus 3 into bracket lambda plus 1 I cap plus 3 into lambda plus 1 j cap, which is equal to minus lambda plus 3 I cap plus lambda q j cap plus 3 lambda plus p k cap. Now these two vectors and these are equal vectors. Then by equality of vectors, corresponding coefficients are equal. So minus 3 lambda plus 1 is equal to minus lambda plus 3. 3 into lambda plus 1, which is equal to lambda q. And here k cap term is absent, so 3 lambda plus p is equal to 0. This is equation 1, equation 2 and equation 3. We solve equation 1 for the lambda. Solving this equation, we will get lambda is equal to minus 3. Here lambda is equal to -3. This minus sign indicates that the division is external division. If there is a plus sign, then division is internal division. Here minus sign, so division is external division. So C divides AB externally in the ratio 3:1. We can't write here as a -3:1. This is not a proper way to write the ratio. -3:1. We can't write it. So here the C divides AB externally in the ratio 3:1. The second is, we have to find this, putting lambda is equal to -3 in equation 2. Here lambda is equal to -3. We will get Q is equal to 2. Solve this. We will get Q is equal to 2. Again lambda is equal to -3 value. We will put in equation 3. We will get value of P. P is equal to 9. So P is equal to 9 and Q is equal to 2. And division ratio is 3:1. This is the example, very important example. Then next question. Prove that the median of a trapezium is parallel to the parallel sides of the trapezium and its length is half of the sum of the lengths of the parallel sides. So its solution, consider a trapezium ABCD. This is the median of a trapezium. What is the median of a trapezium? Median is the line joining the midpoints of the non-parallel sides. This is called the median. So this is the median of this trapezium. And now here A bar, B bar, C bar and D bar. Here A bar, B bar, C bar and D bar. Firstly, what we have to prove? Firstly, we have to prove that this AD parallel to MN, parallel to BC. We have to prove that this median is parallel to the parallel sides. This is our first proof. And second proof is median is equal to, that is MN is equal to half of AD plus BC. MN is equal to half of AD plus BC. So there are two proofs in this example. So firstly, consider this is A bar, B bar, C bar and D bar are the position vectors of the vertices A, B, C, D. Are the position vectors of the vertices A, B, C, D. And position vector of the M is M bar and position vector of the N is N bar. Now, AD is parallel to BC. So these two are collinear. Then collinear, then by definition of collinear, AD bar is equal to scalar into BC bar. That is AD bar is equal to K into BC bar by definition. Now AD bar plus BC bar. Now consider AD bar plus BC bar, which is equal to, but AD bar is what? AD bar is K into BC bar. We find out here. So here put KBC bar. We get common BC bar. So into bracket K plus 1 BC bar. This is equation number 1. So what is the value of AD bar plus BC bar? Which is equal to K plus 1 BC bar. Now M bar and N bar are the position vectors of the midpoints M and N. And AB and DC, these two are non-parallel sides. Okay. MN is the midpoint of it, median of a trapezium. Then by midpoint formula, here M is the midpoint. Then by midpoint formula, M bar is equal to A bar plus B bar upon 2. Here M bar is equal to A bar plus B bar upon 2. And N bar is equal to D bar plus C bar upon 2. Therefore, Mn bar, consider Mn bar. Mn bar is equal to, what is Mn bar? N bar minus M bar, second minus first. That is N bar minus M bar. What is the N bar? N bar we calculate here. And what is M bar? We calculate here. We get subtract, that is 1 by 2 D bar plus C bar minus A bar minus B bar. Now we equate these two terms, that is 1 by 2 D bar and minus A bar equate, and C bar and minus B bar we will equate. Then D bar minus A bar, that means AD bar, and C bar minus B bar, that means BC bar. So AD bar plus BC bar divided by 2, and we calculate here value of AD bar plus BC bar, which is equal to K plus 1 BC bar. So here K plus 1 BC bar divided by 2. This is equation number 2. So what we will get? Mn bar is equal to scalar. This is scalar. Scalar into BC bar. One vector is equal to scalar multiple of other. That means these two vectors are parallel. That is Mn bar is parallel to BC bar and BC is parallel to AD. So Mn bar is parallel, Mn is parallel to AD and BC. This is our first proof. Now our second proof, here we already calculate here Mn bar is equal to K plus 1 BC bar divided by 2, or here we calculate already Mn bar is equal to AD bar plus BC bar divided by 2. So just we have to write, that is magnitude of AD bar plus BC bar. Magnitude of AD bar plus BC bar is equal to magnitude of AD bar plus magnitude of BC bar. That means this is AD, that means this is BC. So Mn is equal to 1 by 2 AD plus BC. That means AD plus BC. Mn, median, is equal to half of the sum of the parallel sides. So this is our example. So in this lecture, we studied section formula and its examples. Thank you.